last thing, and what we're going to look at the lab, called molar solubility. First of all, they make this big word for nothing. It's simple. It's ridiculously simple. They make a big deal out of something ridiculously simple. Okay? Here's the idea. Ready? Step one. Back to my stupid example. Boy girls come to the dance. I look and I see a whole bunch of boy girls together. Then I look out on the dance floor and I see two boys. How many couples broke up? Two. I don't even have to count the girls. I can say if I see two boys free and alone by themselves, two couples broke up. The rest are all together as couples. Good so far? Okay. So I'm able to count the number of couples just based on one of the two products. Watch this. Different dance. All right? Beach Boys. All right? Two girls for every boy. I look and I see a lot of these, not couples, what would you, things. All right? Triples, whatever. All right? Don't come up with other names. Just three things together. All right? And I look out on the dance floor. I see two girls. How many triples broke up? One. Is everybody okay with that? Okay. Now, let's do this. Let's say I have the Ksp for some solid. Let's make something up.
Is it possible that one broke off of two different ones?
Nope. They have to break up. The whole thing has to disintegrate. That's what solubility means. Yes?
Is it like there's only two?
Right. I'm saying this, I'm looking at the whole thing. I got eyes on this whole container, and the only thing I see are those two girls. Okay? Don't care how many boys, don't see them, not measuring them, just counting girls. All right? Now, let's say I do a simple one. Let's say copper chloride. Plain old CuCl single. Copper 1+. What's the Ksp? Concentration of copper. Concentration of chlorine. Easy peasy, right? Okay. So now here's the question. If I know the amount of copper, if I measure the amount of copper, how many chlorine am I going to find?
Same amount.
Same exact amount, right? If I just introduce copper chloride into the water. Now, can I frig with that? Sure I can. What if, like we were talking about yesterday, I put a whole mass of chlorine ions in the water to begin with? All right, I populate this thing with chlorine ions. What's that going to do to the amount of chlorine? Raise it up. What's that going to do to the amount of copper? Lower it down. True? If Ksp stays the same, if the amount of chlorine goes up, the amount of copper chloride, now if I start to throw copper chloride into the water, how many of these are going to break up? Not very many. True? Okay? No longer 1-to-1. But if I could figure out how many copper are in there, can you tell me how much copper chloride broke up? What's the ratio? 1-to-1, right? So if I find the concentration of copper, +1, copper is 6.4 times 10 to the negative 6th. What's the molar solubility? In other words, how much copper chloride broke up? That much. You see it? Right? Okay. Yeah.
Is the molar solubility the same thing as the Ksp?
Nope, not even close. Because notice in the first case it would be, sort of, but not really. Because think about it. If what's the Ksp for copper chloride? Is it on your sheet? Sorry, I should have had these ahead. CuCl. Not there? We're going to make one up. Made up. This does not exist. Don't quote me. All right? 5.7 times 10 to the negative 9th. right?
Yep.
Just made that up. Yeah, it is, I'm right. All right, now, but what's the molar solubility? If we just throw copper chloride into water, what's the molar solubility gonna be? It's gonna be that times that, so it's x and x, it's gonna be x squared, whatever the square root of that is.
And
That's the molar solubility.
Is x 6.4 times 10 to the
No,
negative
no,
6?
no, 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 ignore that. Change gears. You asked me a different question, so I changed gears. Watch again. If I said, okay, I just throw copper chloride into water, right? Then you're gonna have x and x. So the molar solubility is just gonna be the square root of this. Somebody find that for me.
Uh, 7.55 times 10 to the negative fifth.
Okay, so there's the molar solubility. Is everybody good? Okay. Now, separate case. I start with a bunch of chlorines. Therefore, the amount of coppers are much lower. Right? I look into the container and I say the concentration of copper is this, which is less than that. True? So now the molar solubility of copper chloride has gone down because we added all those, big fancy word, common ion effect. In other words, we put some other crap in there and that kept the copper chlorides from separating. Good? Okay, last concept. What if I had iron 3 chloride, right? And I asked you for the molar solubility of iron 3 chloride in a solution. All right? And let's say I just make up a number, made up, do not quote me. All right? And I look and I say the concentration of chlorine is 6.3 times 10 to the negative fifth. What's the molar solubility? How many moles per volume of iron chloride broke up? Look over here. If I do it this way, I say concentration of copper is 6.4 times 10 to the negative 6, so the molar solubility is 6.4 times 10 to the negative 6. Does everybody see that? Okay? Because that's how much copper chloride broke up. If I come over here and I say, okay, I look in the beaker and the concentration of chlorine is 6.3 times 10 to the negative fifth, what's the molar solubility? Don't, if you need a calculator, you're not thinking. Come back over here. If I look in this beaker and I see two boys, how many couples broke up? 2. So the solubility is 2. Agree with that? Over here. I look in this beaker, I see 2 girls. How many couples broke up? 1. So the solubility is 1. I look over here, I see coppers. 6.4 times 10 to the negative 6. What's the molar solubility of copper chloride? 6.4 times 10 to the negative 6. I look over here. I see a concentration of chlorine from just dumping iron chloride into water of 6.3 times 10 to the negative fifth. What is the molar solubility?
Times 10 to the negative fifth.
2.1 times 10 to the negative fifth molar. Why? 3 chlorines, right? 3 chlorines. Yeah, you knew it, but you didn't want to say it because you didn't want to be wrong. Be wrong. I'm wrong all the time. All right? And then you guys tell me, but that didn't, oh, sorry. All right? So, in other words, over here, you count them, and then you say, okay, well, it takes 2 of those, so the molar solubility is only half as much. You come over here, you count them, you say, iron 3 chloride, iron 3 chloride. Well, if I count the chlorines as that, the molar solubility is only 1/3 as much. That's all it is. Guess what? That's nearly the whole chapter. right there. Yeah. Everybody okay?